We're going to go on to the vertical carriage now, but I'll just like to illustrate some problems you'll have, some design faults and some solutions to get around it. Remember that soft drink I said to have? Well, cut up a chute like that. But there's a couple of things you need to check first. This dimension is the dimension that the push rods sit on. So they all need to be equal. So you need to measure each one and see what it is. Mine weren't that bad, they were fairly close. They were 39.7. As you can see here, this particular print is all loose filament. The edges are not square like they should be, so that will cause some problems. Then you have your effector, and that's the other end where the arms go. So in theory, this dimension and that dimension should be the same. Keep the rods parallel. But you measure these and they vary 0.5 millimetre from 38.3 up to 38.8. So there's 0.5 mil error already. And not only that, these were within 0.1 if you pick your spot. These are 39.7, 38.3. Almost 1.5 millimetre difference. So they'll be sitting in or sitting out 1.5 millimetres. Then the other problem is the bores on your linkages are 4 mil, but your screws are 3 millimetre. So already, even though you may have measured it down to the thou and adjusted it, you've got 2 millimetre of travel from max to min. They've used a small screw so as the head won't interfere. However, it needs to sit on there. So that taper does not taper down into that bore, which will keep it secure. That is a flat on the bottom, so that also moves side to side. So the way this should have been done is that taper went down to 3 millimetre, and the other solution here is to use countersunk screws. There's none in the kit, so you need to buy yourself some countersunk screws. The countersunk head will go into that diameter and align it in the centre. I will be turning up countersunk screws, but that's a fix up there. So you need to clean them up, clean up all the crap from inside the hex for the nut. Now, as we said, these ones are loose. The fix around that is to get your aluminium, cut a strip off 5 millimetre, then cut a length 20 millimetres long. Then roll it around something that's about 4 millimetre, say, a screwdriver from your kit, something like that. So roll it round. Then what you have to do is fit it in there. Get something like a tapered pencil or pen, swage it out, and screw that in. That will tend to move, and so when you put the cut in, put it in the direction of the thread. So when it twists it, it's winding it up, not unwinding it. So that's what I've done to these ones. So that's that solution to keep that bearing central. Now another solution, and this is the one I would prefer, but you need some machining equipment. These are designed to go in there like such. Then just put your bearing on and do up your nut. Again, slack that way. When you do up your nut, wobbles that way. My solution is to, instead of having the countersunk going through the countersunk side, put it the other way around. So that way the actual cone of the screw will then align the bearing. So it's just nipped up, no sideways movement at all. The problem is two. The nut is sitting above, and a method that we use is we just get a soldering iron and you just leave it on the nut as you tighten the screw. And when the nut gets to the correct temperature, don't get it too hot, but you just keep nipping it up and it'll gradually pull in. So that's how you make a nut hex in any bit of plastic you want. So just rest your soldering iron on the nut, it'll get warm, and as it warms up you've got tension on that and you can feel it starting to move. Take your soldering iron off, screw it up tight, come back, let it warm up again, screw it a bit more, millimetre by millimetre, and then that will go below that surface like that. You have to cut off that much. You can file it, grind it to bring it flush. Now the reason why you need it flush is because the arm fits on there and it's got clearance. Put the arm there, it interferes. But shrink the nut into the plastic, file that off, and it'll be perfect. Another design flaw with it, this is the adjusting arm. So the rollers are in there like that. But design problem number one, you cannot get it to hook in. So you have to remove the bearing to put it on to take it off. Then you've got this large gap here, which is this gap here. Now that's it loose. To get the play out, just check it with your fingers. That one's loosen that one. That's how much gap is left. If that was designed so that was out and you fitted it and then you screwed it in, fine. This hole should be closer in. You have to take the screw off and the bearing off anyway. So you have to fit it like that. So that could be a couple of millimetre further in. That then doesn't bend this as much, doesn't put the tension on that, doesn't concentrate the stress where this sharp edge is. That should be a radius. Any stress concentrators, the sharp edges are next. So that should be a curve there, a radius. And the other design fault, this is where the nut fits that you actually pull against. You have to have a screw long enough. They've got a hole in there. That's the size of the screw you use. The nut is sitting there. That is the amount of material that the nut pulls against. You've got all this is wasted. No, that nut slot should be down here, or preferably should be just cut on the bottom, like all these. Then this would just fit in, screw to the bottom, and off you go. Because it's there, you cannot spread this open, because the nut, this just comes out this way. There's no nut on the inside here either. So that's that problem. So you have to decide what you're going to do. Are you going to use the Coke cans to get it up and running? Are you going to melt the nut into the back of the plate, then file that down? That's what I will be doing. Are you going to make up bushes for in there? Are you going to use a countersunk screw? These are decisions you need to do now while you're building it. Because once you build it, the inaccuracy when you're trying to calibrate it, you'll just be a dog chasing its tail, and you want to remove as many problems as you can. You'll have to bush this out. If you've got a milling machine, you can put that up, cut it square to say 3.8, 38 millimetre, put these in, mill them to 38 millimetre. Then you're right. Use a countersunk screw, and then that will locate it to that hole. So the movement there is taken care of, and the gap there is taken care of. I will go ahead and melt these in, machine all these down, and then I'll get back to you and we'll take it from there. This works okay. There's nothing wrong with this. Just got to make sure you put it in right. So when I've done that, I'll get back to you.